Welcome to Safety Engineering Briefings. Short, practical insights for software and security engineers. We had a production outage last month. Seemed simple at first. A database connection pool exhausted. But the root cause wasn't a code bug. It wasn't a scaling issue. It was a denial of service attack targeting a rarely used API endpoint. The endpoint itself wasn't valuable. It was a stepping stone. Attackers used it to flood the system with legitimate-looking requests, slowly choking off resources for real users. This isn't a security problem or a safety problem. It's both, intertwined. And that's what we'll talk about today. Engineers often treat safety and security as separate concerns. Safety focuses on things going wrong internally. Bugs, errors, unexpected states. Security focuses on things going wrong externally. Malicious actors, unauthorized access, data breaches. This separation is a mistake. Both deal with preventing harm. The difference lies in the source of the hazard. Safety asks, what if our code fails? Security asks, what if someone makes our code fail? Think about it this way. A safety mechanism anticipates internal failures. Redundancy, circuit breakers, graceful degradation. These are about handling the inevitable. Security mechanisms anticipate external attacks. Authentication, authorization, encryption. These are about preventing the unwanted. But a security breach becomes a safety issue when it causes a system failure. And a safety failure creates a security vulnerability. A common misconception is that security is adding on after the system is safe. You build a reliable system, then you harden it. That is backwards. Security considerations should influence the initial design. How do you handle invalid input? How do you limit the blast radius of a failure? How do you ensure data integrity? These aren't just security questions. They're fundamental safety questions. Another issue is assuming secure automatically means safe. Encryption protects data in transit. But if the system crashes while decrypting, you've lost data. Authentication verifies identity. But if a valid user triggers a bug that corrupts the database, you still have a problem. Security provides a layer of defense. It doesn't eliminate all risk. It changes the risk profile. We need to understand those changes. Let us consider a microservices architecture for an e-commerce platform. We have a product catalog service, a payment processing service, and an order management service. The payment processing service is heavily secured. PCI compliance, strong encryption, multi-factor authentication. But the product catalog service has a less protected API endpoint for bulk updates. It's used internally by the marketing team. A vulnerability in that endpoint allows an attacker to inject malicious product data. This data isn't directly sensitive, but it contains specially crafted strings that, when processed by the order management service, cause a buffer overflow. The order management service crashes. Orders can't be processed. The entire platform goes down. This wasn't a direct attack on the payment processing service. It wasn't a data breach in the traditional sense. It was an attacker exploiting a safety weakness in the product catalog service to cause a cascading failure. The security team focused on protecting the payment data. They missed the potential for a seemingly harmless vulnerability to become a critical safety issue. The root cause wasn't a lack of security. It was a lack of understanding how security and safety interact. Safety and security aren't separate disciplines. They're two sides of the same coin. Both aim to prevent harm, but from different sources. Ignoring the interplay between them leads to vulnerabilities and failures. Consider the potential for external attacks to trigger internal failures, and vice versa. What seemingly minor security oversight could amplify the impact of an internal error. If this topic was useful, take a moment to reflect on how it applies to your own systems. See you in the next briefing.